Hey guys, yesterday we learned about all the different characteristics of quadratic functions given a graph. And all of that is great when you are given a graph, but if you are given an equation, we need to know how to find those characteristics. So the first type of equation we could be given would be standard form, which is typically the most common. And standard form is f of x, and remember that f of x just means y, okay? So f of x would equal ax squared plus bx plus c, where the a, the b, and the c are all different numbers, all right? So that's going to be our most common form of a quadratic equation. To find our axis of symmetry given standard form, we would use the equation x equals negative b over 2 times a. And then to find our vertex, it would be negative b over 2a, and then f of negative b over 2a. And all this means is that once you find your axis of symmetry, you would substitute it into this equation to find your vertex. Alrighty? And just given the equation, what does standard form tell you? Well, our c value tells the y-intercept. And our a is going to tell us if our graph opens up or down. All right, so let's look at our very first example. We have y equals 3x squared minus 6x plus 1. And the first thing we have to do is find our axis of symmetry. So to find our axis of symmetry, it's going to be negative b over 2 times a. So for negative b over 2 times a, I'm going to put AOS right there, and then we have negative b. Well, our b value is negative 6, so we have a negative 6 over 2 times our a, which is 3, which would be 6 over 6. So our axis of symmetry is 1. All right? And then we are going to substitute in that axis of symmetry into our standard form equation. So we have y equals 3, or x is 1 squared minus 6 times 1 plus 1. Okay? And so 1 squared gives us 1 plus 3, times 3. So we have 3 minus 6 plus 1. 3 minus 6 is negative 3, plus 1 is negative 2. So that means our vertex is going to be 1 from our axis of symmetry, comma, negative 2. All right. Our transformations are going to be the same as whatever our vertex is, okay? So remember that x is left or right, and y is up or down. Okay? So if I have a positive 1 in my x, then that means that we are going to the right 1. And with a vertex of negative 2, we're going down 2. Alrighty? Now, we have not talked about shrink or stretch yet, so I'll put it down here. When our a value is a whole number, it's going to be a stretch. All right. When our a is a fraction, when our a is a fraction, it's going to be a shrink. Okay, so shrink is fraction, stretch is whole number. So if we look at our a, shrink or stretch for our a value of 3. So you would go ahead and put the number 3 here. And is that a whole number or a fraction? That's right, it's a whole number, so it's going to be a stretch. And then reflection across the x-axis is if a is positive or not. Okay, so if a is positive, no reflection. If a is negative, yes reflection. So because we have a positive 3, there is no reflection. Alrighty, and if there is no reflection, alright, so in order to tell if we have a max or min given our standard form equation, we are still going to look if a is positive or negative. So when a is positive, there's no reflection and it opens up. When it opens up, that's a U shape, which would be a minimum. And I believe I told you guys wrong last time. We are actually looking at our y values. So this is going to be at y equals -2. Alright, that's my bad. Okay? And then finally, our y-intercept. Well, at the beginning, we said that C told us our y-intercept. So we have a y-intercept at 1. Alright, I just told you guys a lot of information. So take a moment to digest. Alrighty, hopefully you guys had your moment. Hopefully you paused the video. And now we are going to look at problem number 2. So we have f of x equals -7x squared minus 1. So we need to find our axis of symmetry. So negative b divided by 2 times a. So for axis of symmetry, negative b, well, we don't have a b value. So it's going to be negative times 0 over 2 times our a, which is -7. Well, 0 divided by anything is just going to be 0. So we have an axis of symmetry at x equals 0. And then to find our vertex, we're going to substitute that 0 into our equation. So y equals -7 times 0 squared minus 1. Well, 0 squared is just going to be 0. 0 times -7 is going to be 0. So we are just left with -1. So our vertex is going to be -1, 0, whoops, sorry, wasn't thinking, 0, -1. Alright, and for our transformations, remember x is left and right, so no left or right change, but we are going to go down 1. And then shrink or stretch. Remember, we are looking at our a value. If a is a whole number, it is a stretch. Well, we have 7 is our a value, and therefore it is a stretch. Take a look, see if we have a reflection. Because a is negative, we do have a reflection. Alright, and because we have a reflection, that means that we have a maximum. Because remember, if a is negative, then there is a reflection, and it opens down. Well, down is like our roller coaster, and we have a maximum. Alright, at y equals -1. And then our y-intercept is our c value, which is also going to be -1. Excellent. Okay, so now on to number 3, next side of our paper. Now we actually have to graph it, okay? So start by finding our axis of symmetry. Remember, axis of symmetry is x equals negative b over 2 times a. So for our axis of symmetry, we have negative 4 divided by 2 times our a, which is negative 2. Negative negative makes a positive 4. 2 times negative 2 gives us negative 4. So our axis of symmetry equals negative 1. So I'm going to go ahead and draw my axis of symmetry of x equals negative 1. Alright, now it tells us what to do. Plug in the x value to get the y coordinate of your vertex. Let's do it. So then we have y equals negative 2 times negative 1 squared minus 4 times negative 1 plus 2. Negative 1 squared is just 1 times negative 2 will leave us negative 2. Negative 4 times negative 1 gives us a positive 4. And we have plus 2. Negative 2 and positive 2 cancel each other out. So we are just left with y equals 4. So then our vertex is going to be negative 1, 4. So now I can graph that. Go to negative 1, positive 4. Alright. Now here comes the fun part. Alright, we need to choose 2 values to one side of the vertex and find the corresponding y value. Then use symmetry to find 2 more points. Okay? So what this means is that we need to create a table of values. Make sure your vertex is in the middle, meaning negative 1 for y. For x. So negative 1, negative 2, negative 3, 0, 1. And our y value for negative 1 was 4. Okay? So then, we are going to substitute in 0 into our equation, and then 1 into our equation. Alright? So let's go ahead and do that. And I'm going to actually do it by hand so that you guys can see how it works. So, negative 2 times 0, I'm getting the 0 from our table of values, squared minus 4 times 0 plus 2. Alright, so then 0 squared is 0 times negative 2 is 0. Negative 4 times 0 is 0, which means that this is going to equal 2. So right here we have 0, 2. Now I'm going to substitute in 1. Okay, so 1 squared is 1 times negative 2, we're left with negative 2. Negative 4 times 1 is negative 4, and then plus 2. Negative 2 and positive 2 cancel out, so we're left with negative 4. Alright, and it told us to use symmetry to find 2 more points. Do you guys remember yesterday when I showed you guys the table of values and asked you what was special about our table of values? Well, what I wanted you to see was that after our vertex, which is right here, our numbers start to repeat. So that means that at negative 2, it's going to be positive 2. And at 1, negative 4, this should also be negative 4. That's what I wanted you guys to see. That is how our symmetry works. Okay? So now we can actually go ahead and graph these points. So we have 0, positive 2, and negative 2, positive 2. and then 1, -4, -3, -4. And we can connect our dots. Okay. Now that we have our graph, what's my domain? That's right, always all real numbers. And our range, who can figure that one out? Remember, we start at our bottom of our graph and we hit arrows, meaning that we start with negative infinity. And then we're going to go all the way up until our y value, which is 4, with a bracket around 4. Good. All right. You guys ready to try the next one? Let's do it. Okay. If you're not, pause the video. Okay. So for number 4, step 1. Axis of symmetry. Negative b over 2a. So we have -4 over 2 times 1. Because remember, there is a secret 1 in front of our x squared. So -4 divided by 2 is going to give us -2. Go ahead and graph that. Step 2, vertex. Substitute in -2 into our equation. So we have -2 squared plus 4 times -2 plus 7. -2 squared means -2 times -2, which gives us +4. Whoops. And then 4 times -2 will give us a -8, and then plus 7. 4 plus -8 will give us -4 plus 7. -4 plus 7 gives us +3. So our vertex is -2, +3. Graph it. Alright, next step, table of values. So remember, we want to start at -2. Okay. So at -2, we have 3. Whoops, sorry. There we go. Alright, now we want to substitute in -1 into our equation. So we have -1 squared plus 4 times -1 plus 7. -1 squared leaves us with 1 minus 4 plus 7. 1 minus 4 gives us -3 plus 7, which equals 4. Which means that at -3 it should also be 4. Alright, and then we're going to substitute in 0. So we have 0 squared plus 4 times 0 plus 7. 0, 0, 7. So here we have 7, which means that over here we must also have 7. And then step 4. Graph. Alright, so we're just going to graph those points. So we already have -2, 3. So -1, +4. Which means that -3, +4. 0, 7, -4, 7. And connect your dots. Domain, all real numbers. Range, start from the bottom and go up What's that y value right here? It's 3. Remember, it is included. And then we continue to go up, so that's positive infinity. Good. For number 5, I want you guys to try this one on your own. I want you to tell me the axis of symmetry, the vertex, the table of values. Well, you don't have to tell me the table of values, but you need to do it. Graph it, and then tell me your domain and your range. All right? Cool. Now, we are going to move on to number 6, which has everything that we could possibly need. Okay? So we are going to try to do all of these all of these blanks without graphing. We're going to graph last. Okay? So, first thing we need to do is find our axis of symmetry. So that is going to be negative b over 2a, negative 4 over 2 times our a. All right? 2 times 1/2 is going to be 1. So our axis of symmetry is going to be x equals negative 4. All right, if you don't believe me, put it in your calculator. To find your vertex, substitute it in. All right, and you are going to get negative 2. So then our vertex is negative 4, negative 2. Transformations, we are going to go to the left 4 and down 2. We got that from our vertex. Our A is 1/2, so that's going to be a shrink. Do we have a reflection across the x-axis? No, because A is positive. Max or min? We have a minimum because A is positive. And what's that y value that we have a minimum at? Negative 2. Remember, that's from our vertex. Y-intercept, that's our C value. Domain is all real numbers. Alright, range. I wonder who can figure out range without having to graph it. Okay, because you know that there is no reflection across the x-axis, meaning our graph is going to look something like, hold on, where's my vertex? Something like that. You know that it has to do with the y value of our vertex. Our y value of our vertex is negative 2, and then we will continue to go up. Oops. Now, let's check to see if we were correct. Alright, so go ahead and graph your axis of symmetry and your vertex. Alright, and then we need to make a table of values. Hold on. Well, alright, I kind of cheated and went ahead and did it really quickly and used the pretty numbers, okay? Alright, so let's see, I have at negative 6, 0, and negative 8, 6, and then that would mean that negative 2, 0, and 0, 6. And then you can connect your dots. And we look at that. There is our negative 2. And then we keep going up. So we did get our range. That is awesome. Alrighty. And final problem of the day is a word problem. Alright? So, Sam jumped off a cliff into the ocean, into the Acapulco, while vacationing with some friends. His height as a function of time could be modeled by our function, where h of t is his height in feet at any given time t in seconds after he jumped. How long did it take Sam to reach his maximum height? Alrighty, so we want the maximum height. So, it told us maximum. So, that means that we are looking for our vertex. Alright? But because we're looking at how long, and t is in seconds, we're just looking for our x value of our vertex. Which means the axis of symmetry. So let's go ahead and find that. So that's going to be negative b over 2 times a. So we have negative 16 over 2 times negative 16. Alright. So that is just going to leave us with 1/2. Alright. So 1/2 seconds for him to reach his maximum height. Now we want the highest point that Sam reached. So now we want the y value of the vertex. Okay, so we want to substitute in 1/2. So we have negative 16, 1/2 squared, plus 16 times 1/2, plus 480. Alright, well let's see, 1/2 squared is going to be 1/4, because 1/2 times 1/2 is 1/4, plus 16 times 1/2 is going to give us 8, plus 480, and then negative 16 times 1/4 is going to give us negative 4, and then 8 plus 480 gives us plus 488, and then negative 4 plus 488 is 484 feet. Ta-da! And of course you could just put that directly into your calculator, but I like to make things difficult. Alright guys, now you have your activity.